Hello everyone, welcome to the channel. We are learning about the operations on sets. In the previous video we have learned about the union of sets. In this video we will learn about intersection of sets. What is intersection of two sets? Let there be any two sets A and B. Then the set which contains all the elements which are in set A and in set B is known as the intersection of sets A and B. We can define it as let A and B be any two sets, then a set containing all those elements which are in set A and in set B is the intersection of two sets A and B. It is represented as A intersection B. This is the sign for intersection. We can also say having the elements in set A and in set B. It means the elements are common in both the sets. So we can also define it as a set containing all the common elements of sets A and B is the intersection of A and B. So to understand easily we can say all the common elements are lying in this particular set, that is the intersection of the sets. In the set builder form, we can define it as A intersection B is equal to X such that X belongs to A and X belongs to B. Remember the difference. In A union B we had X belongs to A or X belongs to B. Here we have A intersection B is X such that X belongs to A and X belongs to B. For example, let's take two sets A and B. A contains elements 1, 2, 3, 4, 5 and B contains 2, 4, 5, 7, 8. What we find here? The common elements are 2, 4 and 5. It means when we want to find out the intersection of sets A and B, that will be A intersection B containing only the common elements or the elements which are lying in A and in B. They are 2, 4 and 5. This is the intersection of sets A and B. Suppose we want to represent the Venn diagram of it. We know that first we have to draw the universal set U. Sets inside it, they are subsets of it, that is A and B. The common elements are 2, 4, 5, that is 2, 4, 5 will lying in the common area or common region. 1 and 3 are lying in this portion of A and the elements of B which are not in the common area 2, 4, 5, these are 7 and 8 are lying in this. The remaining elements of U will be here. Common region. When we want to represent A intersection B in the Venn diagram, we are finding A intersection B represents the common region. It means this common region of them will be shaded. And this shows that this contains only elements 2, 4, 5. So this is the intersection of the sets A and B. Now suppose the sets are disjoint. When sets are disjoint, disjoint means they do not have any common elements. Like suppose we have a set P having the elements A, B, C, D. Another set Q having the elements L, M, N. don't have any common elements. Then the intersection of P and Q will be equal to phi, that is null set or empty set. This is also a condition for two sets to be disjoint, that A intersection B or P intersection Q is phi. So in case we want to define disjoint sets, we can also define it like this: two sets A and B are disjoint if A intersection B is phi. Here P and Q are disjoint since P intersection Q is phi. When we want to draw the Venn diagram of it, what will be there? This is U, universal set. P and Q, the subsets, because they do not have any common element, they will be away from each other. This is set P and this is Q. P has the elements A, B, C and D. This is having the elements L, M, N. And when we want to represent A intersection B in this, since they do not have any common elements, there is no common region, this will be left just like this only. So remember that A intersection B or P intersection Q is phi if the sets are disjoint. Let's take one example of three sets. Suppose there are three sets A, B and C. A contains the elements 1, 2, 3, 4, 5. B contains 2, 4, 6, 7 and C contains 1, 2, 6, 8. Then the common element in all the three sets A, B and C, that is 2. It means A intersection B intersection C in this will be 2. To represent this in the form of Venn diagram, we draw the Venn diagram. This is the universal set U. These are the subsets A, B and C having the intersections. It means they are intersecting each other. Elements are represented like this. Then to show A intersection B intersection C here, we find the commonmost region. The common region to all the three is this particular region. So this we will be shading. This is representing A intersection B intersection C. Now let's learn some properties. First one is A intersection A is equal to A. As we know, A contains all the elements of A. It means common elements are there, that are all common elements of A, and hence A intersection A is A. This is known as idempotent property or idempotent law. Second is A intersection B is equal to B intersection A. Common elements in A and B or common elements in B and A, meaning same. And this is known as commutative law or commutativity. So we can say intersection of two sets is following the commutativity law, or we can say the intersection of sets is commutative. The third one we have A intersection B intersection C is equal to A intersection B intersection C. As we have learnt in the union of sets also, this is known as associativity or associative law. So we can say that intersection of sets follow the law of associativity, or we say the intersection of sets is associative. The fourth law we can have A intersection phi. In case we want to find out the intersection of A with empty set, do they have any common elements? No. It means this will be phi. Even for A union phi, we can see that that will be A because we have to take all the elements of A and phi. Phi do not have any elements, so all the elements of A will be coming. This is A. These laws are known as identity law. The next law we can take as A intersection U. As we know, A is a subset of U. It means all the elements of A will be common in both, and hence we can say A intersection U is A. It means we can also say the sixth property according to this only, that if A is a subset of B, then A intersection B will be equal to A, because all the elements of A will be lying in set B. In the next video, we will learn about the difference of sets. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.